How many satellites can we fit in Earth's orbit? Only a few thousand functioning satellites may have orbited our globe a decade ago, but there will be tens of thousands, if not hundreds of thousands a decade from now. For years, experts have been warning that Earth's orbit is becoming overcrowded, so how many satellites can we launch into space before it becomes too much? In this video, we will take a look at this very dangerous issue that we are going towards and what we can do to prevent it. Sit back, relax, and enjoy. Jonathan McDowell is a researcher of powerful cosmic events, including black holes at the center of galaxies that create jets at the Harvard-Smithsonian Center for Astrophysics. But McDowell has recently received recognition for his efforts in an entirely new area of space exploration. McDowell monitors the increasing frequency of satellite launches and the ever-increasing mass of objects orbiting the Earth in a monthly digital circular titled Jonathan's Space Report. The original goal of the project was to, quote, create a pedantic historical record of the space age, but it has evolved into a chronicle of the destruction of the ecosystem in the vicinity of Earth. McDowell has been very outspoken regarding the future of the increasingly popular near-Earth space in his many media appearances. Quote, "It's going to be like an interstate highway at rush hour in a snowstorm, with everyone driving much too fast," he told Space.com. When asked what the situation in orbit will be like if existing plans for satellite mega-constellations such as SpaceX's Starlink, OneWeb, and Amazon Kuiper come to fruition, quote, "except that there are multiple interstate highways crossing each other with no stoplights. There are already early warning signals that things are getting tense, but before we go on to the opinion of Hugh Lewis, one that has shocked the world, make sure to hit that like button, subscribe to our channel, and turn on the notification bell from our channel. That way, you'll always be in touch with our latest content. Back to science we go. Hugh Lewis, a British colleague of McDowell's, is also often quoted as a sobering voice of reason, warning against jumping on the new space gold rush too quickly. Professor of aeronautics at England's University of Southampton, Lewis has been tweeting about the rise in conjunction occurrences, or instances in which two objects in space, whether operational satellites or bits of space debris, come dangerously close to each other for several years. Some of his charts really hit home with me. The total number of conjunctions anticipated for 2022 was 134% greater than the number for 2020 and 58% greater than the number for 2021, topping 4 million, as reported by Lewis in a post published on Twitter on January 13th. Lewis told Space.com that this does not suggest that objects in space came close to a collision on 4 million separate instances, but rather that it is becoming increasingly difficult to regulate space traffic. Let's look at Starlink, SpaceX's communication system. SpaceX's autonomous collision avoidance system executed 26,037 orbital avoidance maneuvers with its Starlink satellites between December 1st, 2020 and November 30th, 2022, as reported in a filing with the U.S. Federal Communications Commission, FCC, in December of last year. With almost 4,000 Starlink satellites in orbit now, that equates to 12 avoidance maneuvers per satellite. Although SpaceX has deployed a sizable constellation so far, it is only a fraction of the scale of what the company ultimately intends to deploy. It is possible that by the end of the next decade, 42,000 Starlink satellites will be in orbit. OneWeb plans to launch as many as 4,000 satellites. Amazon plans to deploy 3,200 Kuiper spacecraft. And China plans to launch 13,000 satellites as part of its envisioned Guowang system. SpaceX maintains that its satellites have enough fuel for 350 collision avoidance operations over their planned 5-year lifetime, as stated in the FCC paper. Nonetheless, Lewis's number suggests that this threshold might be crossed in a surprisingly short amount of time. Quote, "The number of required avoidance maneuvers is increasing non-linearly," Lewis said. By about 2027 or 2028, the Starlink constellation might have made throughout its lifetime a total of 1 million collision avoidance maneuvers. And that also corresponds potentially to the earliest time when they reach 350 collision avoidance maneuvers per satellite, per the 5-year lifetime period. We're talking about potentially hundreds, if not thousands of maneuvers a day. In a nutshell, the sheer number of avoidance maneuvers that Starlink satellites will have to make cold force them to run out of fuel sooner than their projected lifetime, which is fewer than 5 years from now. Yet, Lewis applauds SpaceX for their commitment to keeping astronauts safe in orbit. Only 5 years ago, the company didn't even have a single satellite in orbit. Now, they're the largest satellite operator by a wide margin. In the year since the successful launch of its first satellite, SpaceX has adopted a confident stance. The corporation claims that whenever a Starlink satellite is in a circumstance with a 1 in 100,000 chance of a collision, its autonomous avoidance technology makes the necessary adjustments. The NASA danger threshold is 10 times higher than this one. SpaceX told the FCC that it would make a maneuver in the event of any conjunction unless the operators of the other satellite engaged in the conjunction preferred to handle the matter themselves. Yet, operational satellites are only a portion of the dilemma. According to the European Space Agency's estimates, there are 36,500 pieces of space debris larger than 4 inches, 10 centimeters, about 1 million objects between 0.4 and 4 inches, 1 to 10 centimeters, and an astounding 130 million fragments smaller than 0.4 inches floating around in the area immediately surrounding Earth, 1 centimeter. With larger objects crashing into one another at high orbital speeds, clouds of pieces are created. The larger debris bits, those over 4 inches in size, are constantly tracked, but the smaller fragments' trajectories are essentially unknown, and collisions caused by them can occur with no advance warning. But scientists in the field of debris are especially worried about collisions involving 2 huge inert things, such as dead satellites or discarded rocket stages. On January 27th, a defunct Russian satellite and an upper stage of a rocket that launched it flew dangerously close to one another. Because neither object could change its course, space traffic monitors could only watch and cross their fingers that the two would avoid colliding. That time they did, but only around 20 feet or 6 centimeters. Thousands of deadly debris bits may have been created in the worst-case scenario disaster, and they would have remained in orbit for centuries, posing a harm to everything in their path. It's becoming increasingly dangerous to venture into some parts of near-Earth space due to the proliferation of both new satellites and orbital trash, so everyone's asking the question, how many more satellites can orbit the Earth without causing interference? There's no simple answer here. According to Lewis, some orbital velocities are more at risk than others. In particular, Starlink satellites travel in an orbit of about 550 kilometers, 930 miles from Earth. Space junk at this height normally doesn't hang around for very long after they stop functioning. These satellites orbit decay naturally within a few years due to atmospheric drag. Even if their engines fail at the end of their missions and don't propel the vehicle back to Earth's atmosphere to burn up promptly, as many operators promise. Yet, this power of Earth's orbit to clean the air decreases with altitude. Both the OneWeb constellation and the smaller Global Star reside in this dangerous height band. The majority of mega-constellation companies guarantee that their vehicle will have enough fuel left at the end of the journey to safely re-enter Earth's atmosphere. Yet, experts are nonetheless concerned about the possibility of technical failures. The European Space Agency, a vocal proponent of environmentally responsible space operations, failed to retrieve its 8.8-ton, 8 metric tons, Earth observation satellite Envisat from an orbit 480 miles, 772 kilometers above Earth in 2012. The craft is now among the most perilous bits of space junk since it will continue to orbit the Earth for generations. McDowell predicts that humanity will learn the hard way about the natural potentials of Earth's neighborhood in space. The astrophysicist is skeptical that things will remain manageable in the years ahead, despite the assurances of mega-constellation operators. As for the future, that is the big unknown. Could the space sector be obviously stumbling into its own version of climate change? Lulled to sleep by the bravado of young space entrepreneurs? McDowell foresees a time when traffic signals will be installed on interstates, overpasses will be constructed, and drivers will be held to higher standards. He added that there is already a precedence for far more restricted access to space, satellite slots in geostationary orbit located around 22,000 miles, 36,000 kilometers above Earth, and providing a constant view of a significant area of the world, are distributed by the International Telecommunications Union on a first-come, first-served basis. The licensing process for lower orbits, however, is handled by separate national authorities that are under no duty to work together. Space organizations are also being urged by experts to work on a solution to the problem of deadly orbital debris. Demand is low because there is no current incentive to pay for this kind of service. But a shift in perspective could be on the horizon. The United States government released its National Orbital Debris Implementation Plan in July of last year to describe future actions to keep Earth's orbit in order. The current situation is not likely to persist for very long, whatever the outcome. Our greediness mixed with the technological boom have led to the fact that we are in constant need of satellites in the Earth. After all, life wouldn't be manageable without them, but everything comes with its price. What do you think? Are we to blame for the launch of so many satellites into Earth's orbit, or are they necessary in order to keep life as we know it? Please let us know in the comments below, and thank you for watching this video.